chapter. We'll be taking another chapter. Today I'll be taking the metals and non-metals. And over here, guys, would be the similar way, the way we started this, would be talking about the different ways of writing the answers and all. Just give me 1 second. In the meantime, you turn your cameras on and be quick, everyone. Okay. The thing that I would start with first is I was just checking the group and I saw that many of you are not giving the tests, right? The weekly test. What can possibly be the reason behind this, guys? Only 2 or 3 people are giving the weekly test. Tell me, why aren't you attempting the test lately? Okay, you had your P boards. All right, how was it, by the way? How was your chemistry? Guys, what is taking so long? Turn your cameras on quickly. Chemistry was easy. Kasam, Tarun, second pre-boards are going on. All right. And what about you guys? Sachetan? Okay, Abhinav. All right. Anyways, let's get started now. Today I'll be taking. Fine, Abhinav. Right. You have the test. You can give the test, right? You know that is there in the account. Make sure you don't miss it. All right. And like I was saying, guys, right now we'll be talking about the metals and non-metals chapter, and just the way we did it in the last class. We'll be talking about how to write the answers for each and every question when they come. All right. So just share my screen with you. Jasim, Subhapriya, cannot see you guys. Turn your cameras on real quick. Sheeta, Arham, you as well. Observe. All right now. So guys, what you have to do is first, I would pick one of you up. I would give you 30 seconds and I would give you the question to think about it. Then what you have to do is you have to give me the answer to that question. And see, again, I told you in the last class as well, here, giving the right answer is not the thing. Giving the perfect answer is going to be what the target is for today's session. All right. So the first question is, so we are starting with a very simple question. Why do ionic compounds have high melting points? All right. Take 30 seconds to think about the answer and how to arrange this answer. This would be a 2-marker question. Think, how good can you represent this question when this comes? Why do the ionic compounds have high melting? After 30 seconds, I'll be picking one of you up. Okay, 30 seconds are over. Now, Janavi, you'll be trying to answer this question. Take your time, but make sure it's not about, again, it's not about right answer, guys. It's about the perfect answer. There are 2 marks in it. So make sure when you answer this question, you're perfectly arranging everything up. After Janavi says the answer, tells us the answer, after that, guys, I will be giving you the opportunities as well. What else can we add into that answer? Okay. Yes, Janavi, go on.
Sir, ionic compounds are made up of ionic bonds, which are the interaction between positive and negative ions. The ionic bonds are, the ionic bonds are strong in nature, and a lot of a lot of heat energy is required to break this bond. Hence, ionic compounds have high melting points.
You're saying that a lot of heat energies used to break which bonds are you talking about here? The
Sir,
ionic bonds.
to break the force of attraction between the ions.
So you're calling it an endothermic reaction. Okay. So ionic bonds mean, let's say I'm talking about this, generally like NaCl. We are saying the bond between Na plus and Cl minus, this ionic bond, right?
Yes, sir.
To break this. All right. I got your answer. I'll be telling you how much and what is the amount of marks that you're going to get from this answer. But guys, I'm all ears to you now. So what else can we add up in this particular thing that she has said in order to make it more perfect than this, whatever it is? So any suggestions? Yes, sir.
So at the beginning, we can add the definition of basically like just ionic bonds, which is like the bonds caused by the complete or permanent gaining or losing of electrons between two elements having like differing like terminals, like positive or negative. And then at last, we can like add at least one example.
One example, like?
So any example by like probably like like thermal decomposition reaction, probably.
Thermal decomposition reaction, like you have to think about a proper example right now. You're saying calcium carbonate? Thermal decomposition of calcium carbonate, would that work?
So this one I'm not sure.
All right. So you think that you want to add an example, but you're not really sure about the example, right?
Yes, sir.
Anyone who would be able to give me the example for this reaction? Inward electrostatic force attraction. All right. Abida is making a point right now. She's saying that we can add a term called electrostatic force of attraction. That is right. That is a good point to be added up. Electrostatic force. That's the name of the force, right? That is a keyword over here. So that's a point gainer, guys, we can call it. Anything else? Anything else? Any other suggestions? High lattice enthalpy. Do we have lattice enthalpy in our? If you do not have that term in your book, Pratham, you cannot use it. But do you appreciate that? But you know what? All the answers that I have got so far, there is a basic mistake in that answer. All right. Amount of energy needed, that's why the ionic compounds have higher melting point and boiling point. Right, Anik, you are right over here as well. But then again, there is a basic mistake that all of you are doing right now. Is there anybody who can tell me what is the basic mistake there in all the answers that I have written so far? This answer is not really correct answer. There is a huge mistake waiting.
Ionic bonds have like weak inter-atomic forces, but like very strong intermolecular forces.
Weak interatomic forces, are you sure about it? Ionic compounds are solids in nature, isn't it?
Yes.
NaCl is the electrostatic force, and electrostatic force is one of the strongest forces of attraction out there. It's not weak, it's one of the strongest, I would say. That's right, Pratham. You know, all the time when you talked about all these things, you know, you are not understanding that you are talking about interatomic forces. It's not interatomic forces, guys. This is intermolecular force we are talking about here. It's not the force between Na plus of and Cl minus of NaCl. Try to understand this. Let's say this is something I told you while teaching you this. Don't make the mistake. You see that like you are completely ready with the answers, right? But still you're making these mistakes. First, turn your cameras, everyone. See, let's say this is NaCl for us. All right. Now, I'm not breaking the bond between Na and Cl. I'm not breaking it. Because NaCl in a solid state also it's NaCl, in the molten state also it's NaCl only. Am I making sense right now? Let's say water. Water, when it's a liquid, then also it's water. When it's a solid, then also it's water. When it's a vapor, then also it's H2O only. The bond between oxygen and hydrogen is not the bond which breaks. The bond between this Na and this Cl is not the bond which is breaking here. It's not a chemical reaction going on, right, Raman? Right, Abhinav? So we have to talk about first, while writing this, first you have to say that for ionic compound, the intermolecular forces are strong. You have to start from here. Intermolecular forces are strong. Means, what do I mean by intermolecular force now? See, although this is technically a wrong term, but the way they have asked the question, you have to use this term. Technically, this term is wrong. Ionic compound cannot have a molecule. But see, if we have to say ionic molecule, this is how it's going to be. NaCl. One Na plus and one Cl minus together, they make an ionic molecule. But again, guys, that's not the right term. There is nothing like ionic molecule out there. Okay. Now, then again, there is another NaCl. Then again, there is another NaCl. You know which force are we talking about right now? We are not talking about the force between this Na and this Cl. We are not talking about that. We are talking about the force between Cl of this molecule and Na of the next molecule. This is the force we are talking about. Intermolecular force is the force we are talking about. Exactly. Are we understanding this, guys? Tell me. Right, Alan? We are not talking about the water. If we have water, see, I do know that right now. You might think that, sir, I have understood it. But again, guys, this is a red flag. Don't make this mistake again. Although I have mentioned this quite a few times, but still. Let's say this is water. We are talking about the force between two water molecules. This water molecule and this water molecule. Not the force between oxygen and hydrogen. Between this water molecule and this water molecule. Intermolecular force. That should be the first term that you should start with. Other than that, generally every single things are perfect, whatever you've done. So intermolecular forces is the one you should start with. Then you say, like, as it's a strong, it's a high strength because it's an electrostatic force, and to break it, I need a endothermic, and everything now fits properly. Okay, then you can give a definition. And guys, for an example, if you want to give an example, you go like all the ionic compounds are solid in nature. All the ionic compounds are solid in nature. That tells you that they have high bonding. Like example, NaCl is solid, KCl is solid, MgCl2, they are solid. All of them are solid solids. This is how you should write this answer. Are we clear? All of us. Guys, this is the, I have asked you many times now, keep your cameras on. If you have to keep it closed, then take permission from me. I am definitely going to give it if you have a valid reason. Come on, everyone. Anik, Pratham, all of you. All right. Now, are we clear, everyone? So this is how you need to write this question. And one more thing, I told you in the mentoring sessions, those who were there with me in the mentoring sessions, guys, I told you when they give you 2 marks, make sure you add 4 key points in there. You add 4 key points in there. How many key points have we added? We have added 5 key points. So we are in the right region. So ionic bonds, strength. If you want the right definition, then it's fine. Endothermic, electrostatic, intermolecular forces. Examples. So overall, we have used 6 key points. So we are in the safe region. For 2 marks, always remember every key point contains half marks. So for 2 marker question, you have to add 4 key points in there. Example being one of the key points. That's how you should arrange your answers. Let's go for the next question now. Are we clear, everyone? The first question? Clear? All right. Coming to the next question now. Okay. Simply, I will be showing you the question. Then again, I'll be giving you 30 seconds to arrange this question. Then I would ask you to answer the question. So every question that I'm going to ask you today is all of 2 points. So this is 2-marker question. Think about the answer.
Sir, are you moving the screen?
Yes, I am. Can't you see that, guys? The next
Sir,
question is what?
like, it's not visible for me.
Okay, I'm resharing my screen then. Can you see it now?
Yes, sir.
Great. Okay then. Go on, everyone. Take 30 seconds. What are the alloys? This is a 2-marker question. How are you going to define this? Take 30 seconds, then I'll be picking one of you up to answer this question. Go on, Robin. All right, 30 seconds are over. I guess you made your answers now. Vishwesh, you're the one who would be answering this question. So take your time, arrange it properly. Others, think about the answer and make sure when he's missing 1 or 2 points, you tell me right away. All right. Think about the best answer right now for alloys. Go on, Vishwesh. You have to answer now.
Okay, sir. Alloys are a homogeneous substance created by mixing 2 or more metals or metals and non-metals, and typically have better physical characteristics than their constituent substances. An example of this could be bronze, which is an alloy of copper and tin.
All right. Okay, Vishwesh, I got your answer. Now, anyone is there who can make it a better answer? Or should I keep it like this? Because the answer that Vishwesh has told me so far, this is a good answer. Yes, Ashita, go on.
So we can add 2 points. So like how are these alloys formed? So if you're talking about alloys of 2 metals, then they are mixed together in the molten state. And if you're talking about non-metals and metals, then they are formed by dissolving the non-metal to the metal in the molten state. And then we can and then I think you said homogeneous. So it's, yeah.
Great point. How we make the alloys. Like for the metals, we first melt them up and then we mix them together. That's a very good point over here. Yes, Abhinav.
Yes, sir. We can also add that alloys show different properties from their base materials.
Yeah, that is something Vishwas has said, but yeah, how would you enlighten it? Like different, like how different? What kind of difference it show?
Sir, we can give an example saying that iron is soft, it can be easily molded, whereas steel is harder and has more resilience when iron is mixed with carbon.
All right, that's right. So it's kind of a characteristics of alloy that you are adding up. That's nice.
Yes.
Great. Yes.
So even I was going to mention the characteristics, like for reducing the amount of corrosion and all.
Go on. I would like to hear that.
Point like that little point that the alloys usually contain one metal in higher composition, and that is known as the base metal.
Yes, one is in the higher and one is in the lower. So that is something Apratim, we can do it in this way. For let's say bronze or brass, anything that we are showing, there on the bottom of it, we can say this is the base metal and this is The other one, right? The mixing. That's great. All right, guys. Overall, you did well. You managed to find five total points, but then again, if you're finding 4 of them, then also that's fine. The 5th point is only what you're gonna add after when you have a lot of time left. All right, what did I tell you guys? Rather than underlining the main points that is not needed, you write in this way. Like, as you can see, like I'm just putting points in there, right? So write in terms of points so that you can save some time in there, and make sure you add the new points that you feel like after you have some time left, not before that. Try to add 4 points. Try to give an example for each and every situation. For chemical reactions equation, for each and every chapters where you can add an equation, you have to add an equation in there. Other than that, guys, try to add 3 extra points for a 2-marker question. 3-marker question means total 6 key points. That is what you have to add in there. All right. So it's a homogeneous substance. This is one of the major key points that he has said, Vishwesh. Then about the composition, he said that like how is it formed and all. Then the examples as well. And then here Ashita added up like how do we mix them together and how do we make it. And there the characteristics is also fine. We try to enhance the shelf life. We want to enhance its durability, tensile strength, anything like that. You can take an example and add as a characteristics. I would just like to ask you one question, one simple question in here. So who will ask you this question? Krishant, I'll be asking you this question now. You have to tell me, this is a very famous question. Is alloy a mixture or a compound?
So it's a mixture because it can be easily separated through physical, like physical processes.
Is that because it's is that the reason behind why it's a mixture? All right, I'm taking your answer though. Your answer is correct that it's a mixture. But guys, is it completely correct? Can it be separated by physical methods? Yes, Vishwesh, go on.
I don't know. I mean, if it's just physical methods, but I don't. They're not held together by bonds, by chemical bonds, right? They're held together by like with physical forces, I guess. So they're not exactly a compound.
But how do you know that if there is no bond on something? Like, let's say there is this thing in there. All right. How do I really know by looking at this or by doing in a simpler methods? How do we really know there's a bond or not? Yes, I'm gonna give you opportunities, guys. Just give me a second. Let me just read the chats real quick. Yes, yes. But how do we know that the constituents are not really chemically bonded? That's what I'm asking. Very good answer, Anik. That's the right answer. Yes, Ashita, go on.
So basically, like from what I've already said, due to the formation of how all alloys are formed, we can say there's like no chemical reaction going on. So none of the elements of the metals or non-metals are chemically bonded. So yeah, that's why it is
like,
a mixture.
Then the question again comes: how do you know that there is a chemical reaction occurring or not while formation of alloy? Like, let's say you don't really be there, right, when the stainless steel is being formed. Stainless steel is given to you. Now, from that, how do you really understand whether it's an alloy or a mixture or a compound?
So it's basically mixing. So like, how do we identify a chemical reaction? It's basically like we have 4 criteria. If 4 things happen, such as and gas is evolved or heat is evolved, or
color is
or
being
what,
changed or something, right?
Yeah, is color changed, being state is changed, and all that. So none of those happen particularly that signify that it's a chemical reaction.
All right, I'm taking your
It's
answer.
just a.
Take your answer. Janavi.
Sir, I wanted to say the same thing, that in alloys, the constituents are just physically mixed and no chemical reaction takes place between the constituents, so it can't be a compound.
Okay, I got your answer. Farham?
Same thing, sir.
Just looking for a particular term right now that I have got in the chat from many of you. But yeah, just go on. Okay. Yes, but I guess, Jasim, you have already said the right thing in the chat. The thing that I was, looking for is they retain their physical properties. If you mix copper and zinc, the properties of copper and the properties of zinc are going to be there. Krishant, remember one thing. Alloy is a kind of a mixture that cannot be separated by physical methods. That's why this controversy came into the picture in the first place. They are not being separated by physical methods, but still, how are they how are we calling them mixture? They are not being able to, we cannot separate them with physical methods, but as there is not a new molecule getting formed. It's not a new thing. Brass is not a new thing. Bronze is not a new thing. Whatever the metals are there, they keep their basic properties, physical property. That's what tells us that it's a mixture, it's not a compound. This is something you can add in here, guys. This is going to be a very powerful key point in here. It's just a mixture as the metals keep their physical properties intact. Now, all these things, always remember, don't overwrite anything because everything has a word limit. Make sure you put 4 key points in there and leave the question right away. Because if you just keep on putting the points in over and over again, what would happen is you would have a shortage of time. Now, to understand how much you have to write, how much you have to, like after what level you have to leave, you have to give mock tests for this. Take tests, give tests more and more, and see how perfect can you make it. Because guys, there is always somebody better than you. All right. So you have to make sure that as you are going to give the test, as you know the answers, you should get the full marks in there. And getting full marks is not going to be very easy for you. Knowing something and reflecting that knowledge in the paper is 2 different type of arts. Okay, so make sure you learn how to reflect what you know. All right, now coming to the third question now. All right, this is a 3-marker question that I have right now in front of me. Think about the answer. I'm going to give you 45 seconds. Think about it. Then I'd be asking one of you to answer this question. Make sure every one of you are ready with your answer. All righty, be quick. "45 seconds are up. So, who will be the lucky one to answer this question? Abida, you give it a try.
Yes. Metal oxides are oxides which react with, amphiphilic oxides are metal oxides which react with both acids and bases to give out water and salt. One example is the aluminium oxide, and another one, no, it is Al2O3.
Al2O3. All right. Okay.
And another one is ZNO, zinc oxide, and we can write the reactions with both base and acid. So I will give it for aluminium oxide first. Al2O3 plus HCl gives you AlCl3 plus H2O. We need to balance this. It will be 6 HCl and 2 AlCl3.
All right, great.
Next one is Al2 with the base, Al2O3 plus NaOH gives you NaAlO2 plus H2O. Then with the zinc oxide, we'll write first with acid. ZnO plus HCl gives you ZnCl2 plus H2O. we need to balance it. So 2HCl. And then second O plus NaOH gives you Na2 second O 2 plus H2. Balancing 2 NaOH. Yeah, that's so.
So Al2O3 with NaOH gives you H2O, but Zn with NaOH gives you H2, right?
H2O, sorry.
Okay, H2O then. All right. So this is the answer I have got so far. Yes, this is a good answer, but let's see. Is there anything that we can do about this? Go on. Anyone who can make it better. So like, let me choose somebody here. So Chetan, let me make it better. Anything that you feel like we can add in there.
So we could add that they have both skeletal basic properties, and that in some reactions they react as acids, so some bases.
Right? Right. That's a very good point that you're mentioning right now. Show me, where should I write that it is showing the acidic character and the basic character?
So like in the order of the point.
Just speak a little bit louder.
So in the order of the point.
Yeah, it's fine. Like in here, you can see that thing happening. That point that you're trying to mention, na, that point is here. From this reaction, you can make that happen. Just tell me, where is Al2O3 acting like a base and where is Al2O3 acting like an acid?
So when it is reacting with HCl, it is acting like a base.
Very good.
It is reacting with NaOH, is acting like acid.
That's right. All right. So here as well, this is going to be a base. That's a very good point over here. And here as well, that is acting like an acid. All right. This is something we can definitely add in there. Just a second. Let me just pick some up here. Subhapriya, would you try to add something else in there? Anything that you feel like?
Another example?
No, don't worry about the examples. There are many of them so far. It's more than enough. Another example, like this is perfect, but just try to give something in there that's going to make it beautiful.
How are amphoteric oxides formed?
Nothing?
So we can write how are amphoteric oxides formed?
How an amphoteric oxide is formed?
Yeah.
Okay, I'm interested. Tell me, how are you going to write that?
I'm not sure.
All right, fine. Steve, I am not willing to increase the number of words anymore. Try to keep it short, whatever point you want to add, because there are two examples in there. There are example here, the metal oxide reacting with acid and base. We can add one more point if you want to, but guys, keep it short. Yes, so they can accept or donate protons. Yes, Vishwesh, we can add that. Okay, yes, sir, go on.
So like we can list like one of the uses of each oxide, like Al2O3. Yes, sir.
Oh no, that's not needed here. That would be over exaggerating the question. Don't go beyond what is being asked. Anything that we can just modify. Anything. Yes, Jason.
So for the within the equations, we can add the physical states.
We can add the physical state. That's something we can do. That's right. So would you be able to tell me what are the physical states are you about to write in here?
Yes. So for Al2O3, it'll be solid. And for HCl and NaOH, it'll be aqueous. And for the salts also aqueous. And water is liquid.
That's fine. What about these ones?
These ones will also follow the same pattern.
When the salts are being formed, they're solids in nature. All right. But yes, as you're saying aqueous, that's not really a problem in there. All right, I got it then. So we can add this, but don't you see there is a room of doing something in here, which is writing the name of these two things. Isn't it? Very simple. But this thing is something, which is needed. If I do not write the physical state, that is fine. But the names are needed to be there. All right, Abida? Everything about your answer is perfect. Just try to add the names in there. And yes, Sachetan's modification is also very nice. Like in a amphoteric oxide, they have both the character, right? See, there are two types of oxide. One is called neutral oxide, another one is amphoteric oxide. Neutral oxide is carbon monoxide. All right. So an amphoteric oxide is Al2O3. What is the difference between them? Neutral oxide behaves neither like an acid nor like a base. Amphoteric oxide behaves both like an acid and base. Right. So considering that, you have to write in here that over here Al2O3 like it's behaving like a base, here it's behaving like an acid. That's a very good modification that you can have done over here. Along with that, just write sodium zincate, sodium aluminate. That's it. All right. So guys,
Yes.
do you remember I told you how to figure out whether the oxide is neutral or not? Do you remember that process that I told you at that day? Like metal oxides are basic, non-metallic oxides are acidic. But there are like carbon monoxide is a neutral oxide. How do we know this? I told you a process. Don't you remember? Like the number of elements that we have divided by the number of oxygen that we have. If the value comes less than 1.5, then that is neutral. Do you remember, guys? I taught you this particular trick I taught you. When the number of element by the number of oxygen comes less than 1.5, that's a neutral system. Do you remember this? Have you forgotten? Doesn't feel like you do remember. So anyway, this is something I have taught you. You can check the recordings. I have taught you this. Do you know from this particular theory in 24th Jan's paper, there was a question in JEE paper that I'm talking about. They have given the list of oxides. They're asking which one is the neutral oxide. All right. From this particular equation, you could solve this. All right, Tarun, clear? Fatima, Supriya, are we clear with this? Try to give the names of these things. Other than that, everything is fine. All right, guys. Now, moving on to the next question. Pratim, keep your camera on. Abhinav, you as well. Simple question. Make it perfect. Thirty seconds for you to think about.
So this is how many minutes?
2. All right, now let's pick one of you. Answer the question. So, Tarun, you try it. Come on, let's start with something. Whatever you feel like, and after that, people would be there to modify your answer. So no worries. Tell me, whatever comes in your mind. I would help you. Which gas is produced when dilute hydrochloric acid is added with a reactive metal? Good, Abhida. That's right. Yes, Sachitan. Yes, Arham. All right. So Tarun, are you going to pass this question then? Speak up, dear. That is the right answer. Just speak up.
So you're asking me?
Yes, I am asking you.
Okay,
Your
I
name
thought
is.
it was someone else.
You are
I
telling
couldn't
us.
hear you properly. I couldn't hear you properly.
Okay, now you can hear me now. Go on.
Yeah. So when HCl reacts with metal, like metal hydrogen gas is liberated.
Okay.
For example, magnesium plus hydrochloric acid will give you magnesium chloride plus hydrogen. So
Oh.
here hydrogen gas is liberated.
Just
Yeah, Mg plus HCl, MgCl2 plus H2.
all right. And
Yeah.
there's the second part of the reaction.
Yeah, so Fe plus H2SO4 gives you FeSO4 plus H2.
Okay.
The reaction with iron, yeah.
So all the three things that you have said, that's perfect. Everything is correct. But let's see, can we modify this thing or not? Fatima, would you try to modify it? Fatima, are you saying something? Because you're not audible. Good point, Janavi. I would like to hear that from you. No, dear, I cannot hear you, Fatima. Will you try it again to speak in the mic? Can. Oh no, you are not. Let's try to rejoin right now. All right. Let's see what you can do with this. Okay. Yeah, just raise your hand if you feel like you have a better answer than this. So I have 1, 2, 3, 4, 5 hands raised. So I would be asking this question now to Alan. Think about this, Alan. How can you modify this? Others, keep your hands raised. There's a lot that we can add in.
So do we add it? Do we write it in the word form like when metal reacts with hydrogen gas, HCl, it produces hydrogen gas?
Okay, yeah, we can do that. We can do that. We can just write it in the word form that it produces hydrogen gas. That's right. Okay, I'm taking your answer. Yes, Abida, go on.
So we can, for the equation, we should firstly balance it, then also write a physical state. Also next to H2, if we can make that arrow mark.
Great. We can show it an upward arrow, we can balance it, and we can write the physical state. Right, Amam? That is right?
Even for
yeah, even for the next one as well. That's correct. Yeah, Ashita.
Yes, I think we can add 2 points. So first is that if that hydrogen gas is released, we can also add that it is a reaction between any acid and a metal, and in this a salt and hydrogen gas is produced. And for FeSO4, we can write it as ferrous sulfate, and it is light green in color. Yeah.
Okay. Name and color.
And also that how to check if S2 gas is released, we can put a burning candle over the top of the test tube, and it would what do you say? Extinguish with a crack.
Pop sound.
Pop sound.
That is something you would like to write here, not in here, because in this equation they haven't asked you to write anything. So just add it in this side. All right, Shika. Very good. Janavi.
Sir, I wanted to say that we can add the reason why hydrogen gases evolve. So, sir, we can say that it is said that reactive metal is added. So, acid is added to reactive metal, and since the reactivity of the metal is more, so the metal will displace hydrogen from hydrochloric acid. That's why hydrogen gases evolved along with the formation of salt.
Exact thing I was waiting. See, when they are saying which gas is produced when dilute hydrochloric acid is reacted with a reactive metal, they are asking in a different way, say that copper, silver are not gonna do that, make that happen, because they are not that reactive. All right, so saying that the metals, those are below hydrogens, they cannot replace this thing. So while you are doing the word equation, you just write, however, for the metals, those are below hydrogens in the list of the reactivity series, they cannot make that happen. Just writing this is making your question writing quality better than any other students right there. See, guys, again, if you try to understand this, we are not really trying to write more. We are trying to make our quality better than the others. Whatever we would write, that would be so informative, that would reflect what have we done in askIITians. All right. So this is a thing which would take your quality in a level up. All right. So I don't think so. You'd like to add anything else, guys, over here? Any other things that you would like to add? Pratham, are you satisfied?
So in the second, you can also add these states, but yes.
Yeah. That's
Second
fine only,
equation.
right? Yeah. The second equation here only, right?
Yes, sir. That's it.
It's fine. The states are. See, states is something that you'd be writing in the end. If you have a lot of time, you just come back and write states. But guys, writing the equation, then balancing it, then try to find the logic which is an exception to that thing, is going to make the answer very unique. Finding an exception to that particular thing that you are writing is going to make it unique. Like, you can add this exception as well. You can't really, right now it is hydrochloric acid and H2O4. For HNO3, you can go like this. Note in that way, HNO3 gives you water instead. Don't write excess. If you want, I'm just giving you options, right? If you give HNO3, then you would be getting water instead of hydrogen. You can add that, or like try to add an exception in to that rule. If you have some time, then again, these are not necessary. These are all you are doing to like create an impression on it, on the teacher, right? This is something you're doing extra just to make your copy better than others. So this shouldn't be something that is decreasing your time. So that's why, guys, you have to write more. You have to give more and more full syllabus tests. Then only you can make it better. All right. Although you feel like I know all the answers right now, I have revised it quite a lot of time, but you can clearly see that, guys, there is lack in your way of writing. There's a lot of things lacking, right? Okay, so the last question of today's session. Think about this for 30 seconds, and then I'd be asking one of you to answer this question. Write an equation for the reactions iron with steam, calcium, and potassium with water. This question is actually of 2 marker or 3 marker. Anything can be there. It can be 2 marker, it can be 3 marker. Think about this question, guys. You can write it very well. For her, is your mic working now?
So in the second bit, like, is it all together, or like we can divide in different bits, like calcium and water, like differently, and potassium?
Yeah, they are asking you differently. Consider it to be a 3 marker question only, as there are 3 questions in there. All right. In that case, Farah, you try to write the answers in the chat field for this question. All right, guys. I guess you're ready. Let's see, who can I pick up? So, Krishant has answered, Tarun has answered, Sachethan, Arham, Janavi, Supriya, Alan, Vishwesh, Apratim. You answer this question.
Okay. So the first reaction will be 3 iron plus 4 H2O gives Fe3O4 plus hydrogen gas, 4 hydrogen gas. So in the, below the water we can write steam.
Yeah.
And so rest all yes sir, that's it.
Okay, going to the next question then.
So calcium and potassium and water will be Ca plus H2O gives COH whole twice, which is a white PPT plus hydrogen gas.
This is a white PPT?
Yes, sir.
Okay. Then?
So then we can write potassium one also. Okay, sir. Yes, I do. Sir. So K plus H2O gives KOH plus H2. And so then we can balance. So 2. So no, so not there.
Hmm?
So not there. So in front of K and in front of this. And also this.
This means?
Yes, sir. And then
KOH.
hydrogen, that is H2O and KOH. Yes, sir. So H2 also.
H2 also?
2. Yes, sir. It's balanced. And so we can also write the that gas here. This is soluble, and yes, that's it.
That's soluble. Okay, got your answers. Now, any takers for any improvement in this question? 1, 2, 3, 4. All right, yes. Let's see. Let's see. Yes. All right. Let's start with you, Anik. You go first.
Yes, sir. So along with the reactions, we can also write it in the statement form, right? Like a formation of iron oxide and hydrogen when reacts with the steam.
So you're gonna write in the statement form. That's right.
Yeah.
We can write one lines in all the cases, right?
Yeah. Each reaction you can write the statement form,
yes,
as well as the products, the reactants, as well as the products formed.
That's right. We can do that. That's correct. Fine, Anik.
Yeah.
Then who should I ask? Ashita?
Yes, so in this, I would first like to add that KOH2, calcium hydroxide, is a soluble and not a precipitate.
Calcium hydroxide? Oh, calcium hydroxide. Okay, this is soluble, right?
Yeah.
Okay.
Yeah, so for the first one, we can write that Fe only reacts with steam and does not react with cold water or water in general, as it's not that reactive. Potassium is very reactive and can react vigorously with cold water. And it is a very exothermic reaction, so the hydrogen gas produced, it catches fire. And
is this what you're saying? Because
yes, sir, I'm coming to that.
Yeah, you are talking about the comments right now, right?
Yeah.
But other than that, like I said, it's a 1-marker questions. So I'm trying to make it sleek. I'm trying to keep it sleek. Rather than writing the entire thing as exothermic, just write heat after that.
Yes, sir. So for calcium, I think we can add that like the hydrogen, like the bubbles would stick up to the metal and it would float.
Okay. All right. Got that. Anything else, Sheeta? Okay, that's it. Go on, Anam.
So we can add the name of Fe3O4, like ferrous sulfuric oxide or iron like 2,3 oxide.
Very good. This is something that I was waiting for. This is iron 2,3 oxide. This is something which is special in here, isn't it? It's ferrosulfuric oxide. You have to write there are two. This is a mixed oxide in there. Try to understand, what is special in this reaction. Why are they giving this reaction? So ferrosulfuric oxide is not something that is supposed which is find very easily, right? The ferrosulfuric oxide, you need to write the name, and if you can't, iron 2,3 oxide. Then again, guys, I told you a number of times, making it a better answer doesn't mean that you would be writing more. Don't write more. That would take your marks away, because there's a word limit to everything as well. That would take your time away as well. Try to make it as sleek as possible. Okay, only the things which are necessary, only the things which you feel like you can just add it, and it can make the answer a little bit better than whatever it was. So this, so far, I am satisfied with. I am going to give 1 marks for each one of them. And guys, this is kind of a, if you write in this way, definitely there is no one can cut your marks in there. All right. So right now I'll be keeping it up to this for today, guys. In the next session, we'll be taking acid, bases, and salts, and metals and non-metals, some questions. So make sure you come prepared, and you just go to the NCERT questions a little bit. All right, and try to solve full syllabus exam questions as much as you can, so that you can manage the timing, and so that you can give your best over there, guys. You have done really well so far. Like in this entire year, you know all the right answer, all the answers, what is supposed to be the answer, right answer in there. You know everything. It's just the representation that we are learning right now. So make sure you put your effort on it a little bit, because guys, like I said, there is always somebody better than you. There's always room for improvement. So try to be the best in that. All right. So that would be it for today again. Bye, everyone. Good night.
Thank you, sir.
Thank you, sir.
Welcome. Bye. Bye.
Sir?
Yes.
Sir, I had my pre-board today, I told you, right? Sir, discuss some questions.
Yes, definitely.
There is only one question. Sir, just a minute. I will just take my question paper.